This is the introductory lecture for CS332, Organization of Programming Languages. And the goal of this lecture is to give you basic information on the course, specifically identify the major course themes. You should always ask, why are you taking this course? We require this course in the computer science and in the software engineering curricula. There's probably a reason for that. So we'll talk about the major themes and what you should learn from this course. Talk about how we're going to deliver the course. As you know, we're online this semester, so we will have online notes and online lectures. I'll have these slides put up online. I've also got other notes for the other modules, and recorded lectures, and then live online lectures. The deliverable types, what are you supposed to do here? I say quizzes. There's one quiz. There's one quiz just in the very just for this assignment, and it's trivial. It's basically, hey, did you even look at this stuff? Kind of questions. And then assignments, some software programs, and some small reports. Normally, when we do this in person, I have fewer assignments and 3 major tests, and so I've eliminated the major tests and replace them with more assignments, basically breaking the tests up into assignments. And the reason is putting a high stakes thing online often doesn't work out very well. So there's the assignments, some software programs to give you experience in working with paradigms you may not have seen yet, and then a couple of small reports. I think it's important to have students write reports in their undergrad experience so they learn how to write. You should be able to identify the course outcomes that are listed on the syllabus, familiarize yourself with those. I'm not going to spend a lot of time right on the lecture here. In the live lecture, we may talk more about those, but basically you can read that, so I'm not going to duplicate that effort. Look at the course grade breakdown. I do everything on integer-based points, no partial points. So the assignments are worth 330, software programs 150, reports are 80. That's a total of 560, and then your course grade is based on that. Just 90% of that is an A, and 80% of that is a B. Oh, I've got a typo in my slide. There will be some extra credit opportunities that get announced along the way. Those tend to be ad hoc. I do bribe you to do the course evaluation at the end, and since this is the first time we're doing this as online delivery, the course evaluations will be very interesting to read. So the major themes of the course, right? Why are you taking this course? Well, if you're going to call yourself a computer scientist, and many of you are, you should know the formalisms of computer science. And if you're going to be a software engineer, you should be familiar with the different paradigms and how they relate to each other. So we talk about formal language theory here. In other words, the course is about organization of programming languages, but this is not really a programming class. It really talks about the formal theory that ties all programming languages together and that ties all programming paradigms together. So we talk about language definition. I think there's a nice robust discussion going on right now on the discussion page about that. We talk about languages and grammars, the difference between the two, and the grammars that we will use are called Backus-Naur form. That's the first section of the course that we'll get into. And the Chomsky hierarchy, which is a way to categorize languages based on certain characteristics, which end up being providing limitations as to what those languages can be used for. We'll also talk about computation and computability. We'll provide definitions for computation and spend a fair amount of time working with a model of computation called the lambda calculus. We'll also do models of computation that are more computer-like or machine-like, so finite state machines, stack machines or push-down autonoma, and Turing machines. For the Turing machines, we cover them fairly briefly. You could take an entire course on Turing machines, but enough so that when you graduate, you know what they are about, what their goal was, what their limitations are and how they relate to the theory of computation. Knowing what's computable and not computable is a good thing to know, because if you go out in the real world and people ask you to design software that is literally not capable of being produced because they're trying to ask you to compute something that's not computable, it's probably a good idea to know that before you accept the contract. And then we'll talk about programming paradigms. This is the closest part that matches the title of the course, right? Organization of programming languages. So we'll talk about how programming languages are grouped into different kinds of paradigms. Virtually all of you at this point have seen a form of the imperative or procedural paradigm. That would be C, the way you use C++ in CS332 if you took that course, or I'm trying to think, MATLAB, that's the one I wanted, MATLAB. And object-oriented, to get in here you had to take CS225 or get credit for CS225, so you took some kind of an object-oriented course topic. And we'll introduce a new paradigm here, functional, which is the first time most students get a chance to see the functional paradigm. And then talk about others. There are other forms out there. And then there are actual programming exercises in the course, mostly in the functional paradigm, because you guys already know the other stuff fairly well. That's what got you here. So we'll do the functional paradigm, and then we'll do an assignment where you do the same problem once in a functional world and once in an object-oriented or procedural world, and gain experience in how you actually resolve the problem or think of the problem differently based on the paradigm that you think you're going to implement the procedure in. Overall, the focus is on clarity of thought, knowing what you know. It's good to know what you know. It's good to be able to state what you know. And having that kind of clarity of thought on these basic topics often will lead to clarity in your solution. Okay, here are the course outcomes that are listed on the syllabus. And like I said, I'm not going to go over these in detail right now. During the live lecture, obviously we can do more, and by all means ask questions, but you can read them. They're on the syllabus. You'll have these notes. So take the time to read these things. And more importantly, at the end of the course, or as we're going through the course, look at them again and ask yourself, boy, did I really get that? Do I really need to get that? Or, do I need to go back and look at that stuff? Our policies, we're doing the lecture. Everything is online, so the live lectures will be online via Zoom. The meeting times are still to be determined. There's a poll up. Take the poll. It may not be traditional. It may not be where we do the same time every week. We'll see how that works out. I think I asked the question, are you open to looking at non-traditional ways? And so far, something like 80% of the respondents said, sure, let's take a look at that. The lecture is supplemented with online notes. The lectures will be recorded and shared on Canvas, but beware, Zoom limits how many lectures we can have, and sometimes they mysteriously disappear. So if you're thinking, well, I'll skip the lecture and watch the recording, there may be no recording to watch, and that may be something I have little control over. Normally I have office hours at set times, but what I found teaching, I taught online over the summer, what I found doing this over the summer is for each week announcing different times, I was able to accommodate more students. And as always, if you need to get a hold of me, then just reach out to me and we can always try to find a time where we can meet together, or usually we can resolve things via messaging. When you do reach out to me, please do so via Canvas messaging, not email. Anything course related, go through Canvas on. The Canvas discussions, I'm not grading those, but they're there to ask hopefully thoughtful questions and get some interaction going between you guys. I hope to see nice arguments, nice, polite, respectful arguments among the students in the class about the topics that I bring up. where you try to justify your solutions to things or the answers to the questions. And the idea is to get to some of the foundational topics, and often I'm using them as a way to introduce the topics, to introduce the next modules. As I said before, Canvas assignments, I'm replacing the high stakes test with the smaller, lower stakes assignment. Some of them might be offered in a test-like fashion. You know, a standard way to do this online is to have the assignment visible for only one 24-hour period, and you have to have the test done or the assignment done in that 24-hour period, that kind of thing. There's 4 programming assignments. They are relatively small. The idea, again, is to get you to understand what functional programming languages are about and how to use them. And yes, if you like Python, you have a functional programming language on your hands. So the idea is to get you used to that different way of thinking. And then 2 small reports. The idea being to give you an opportunity to practice your writing skills. And you know, my experience is that all of us need to practice our writing skills as much as possible. So I'm going to stress quality there as much as content. And by small, I mean this isn't something that's supposed to take half the semester for you to do one, you know, or anything like that. Okay, let's look at the schedule. This is also posted online for you. And as you see, I've broken the course up into modules, because CTLE told me I should break the course up into modules. I took a class 2 over the summer on this, so we're all learning. And let me see here. I've got 10 different modules, 11 if you count this one, but 10 different modules. We start out with languages and grammars and talking about what is a language and how do we define them using grammars, and talk about something called the Backus-Naur form and extended Backus-Naur form. As you can see, we spend 2 weeks on that, so that's a fair amount of time. The rest of these modules are about a week each. They're intended to be about a week each. From there, we go to models of computation, and what that does is it ties the idea of languages to machine models of computation. And so models of computation, I break it up into 3 sections based on the 3 major machines. The finite state machine, which many of you saw in CS332, the push-down autonoma, or PDA, and the Turing machine. And so what we'll do with the first 2, the FSM and the PDA, is actually have you, here's a language, here's a grammar, you give me the machine, show me how the machine works. For the Turing machine, because again you can take an entire course on the Turing machine, we'll just have a brief overview of how it works. Give me a notional idea of how a Turing machine might solve this particular problem. But then more importantly, we're going to get into how the Turing machine was used to define the boundaries of computation. From there we get into more practical things. We leave the theoretical world and get into the more practical world. We talk about compilation for a while, lexing, parsing, semantic analysis, optimizations, that kind of thing. These things are good to know. In the old days, you would actually have to take a course completely on compilers, and you would probably develop your own compiler as part of that course. For this, though, nowadays there's so much software that builds compilers for you, you'll probably never actually build a compiler. But it's still good to know what a compiler is doing and how it's mangling your program, basically. Notice, by the way, there's no holidays here, and the reason is the university wanted to move the schedule around in such a way that when we go to the second half of the semester, you leave for Thanksgiving and you don't come back. So you don't bring, you know, the virus back. So the remaining modules, we talk about lambda calculus, which is another model of computation, more mathematical, which leads directly into functional programming, and then the rest of the course is about the functional programming paradigm and the other programming paradigms. And that's it. That's the course. So we'll talk about this in a live lecture on Monday, and then we'll get into the course topics on Wednesday and Friday, and these lecture times will be announced ahead of time. Have a nice one.